Well, I thought it was time I did an update because God, it must be last week when I did a video. So, all my new coils are wound, and I've even got a fan on there now, and it's actually running. I'm just testing the fan at the moment. So, I've been testing for airflow because, as you know, in the previous design, I had an issue where the drive coils actually melted. Well, they're actually over here. Yeah, they actually melted because during certain testing situations, when driving them with extra current, I want to have a bit of an insurance. The fan isn't supposed to be running all the time because once I get this efficient so that it's drawing very little current, I won't need the fan. But I thought, well, I don't want this melting problem to happen again because it really is not a nice situation because things melt and then you can't get them out of the unit because the draw slides into the bottom there, as you can see, and that's when all hell breaks loose. So anyway, the new fan is it's a double fan. It's a CPU dual. It's a dual CPU fan actually. So I don't want to short anything out. I've got it cooked up with that battery right now. I've got to be very careful. There's a fan underneath, draws air in through the bottom. You can't really see it properly. I don't want to catch the fan on the wires either. So there's a fan underneath, right, and the back to back, and there's a fan on the top, and the air blows out the side of the fan into the unit. Just to give you a rough idea, if I take one of these coils out, air blows all the way through these, and it's hard to believe that, but yeah, there's a little channel underneath that allows the air to blow all the way through, so air is actually coming out at this end here. And the best way to show you that is to pop one of these out, this coil at the end. If I pop that out, right, now if I get my lighter, and stick it down here, right, there's the flame, watch this, it's blowing the flame out. So there's loads of air coming down that little channel. It's like a tunnel. So the air comes out there, it blows across through these laminations, because the laminations are actually dual purpose. They serve as my magnetic coupling, and also because they're in the close coupling to the coil itself, they'll absorb a lot of the heat from the coil. Then the air blows between the gaps. There's some actual gaps in there because I haven't got steel laminations all the way through. So some of the air will blow at the bottom. I don't know if you can see through the... Well, you can't see through the bottom there because unless I shine a torch underneath. But yeah, let me just pop that out. I've got a bad connection somewhere. I don't really short anything out. So this is my coil, my last one I've wound. So I've wound 3 coils, all exactly the same. Each one is 3.3 ohms DC resistance, and the air blows through the little gaps. You can see through it now, look. You can see the light through there. So the air blows up through the gaps and out the bottom through that bit of blue and white felt material. I need to put a filter on the front end actually so it doesn't suck any dust in really, and take them little felts out because yeah, kind of back to front really. But so the air blows all the way down, so I won't have any thermal problems. That's one good thing. So it's like a bloody wind tunnel, this thing. It's only tiny, but there's a lot of air coming out of there, as you can see. I'll just get my lighter back out a bit more. It just blew my lighter out actually. So, and then there's my laminations in the top, and the air blows in between those, so some of the air actually goes straight through to the other end. So each one, this is my adjustable timing. I can move this, advance and retard my timing. Yeah, so anyway, I just thought I'd show you that. I hope I don't get my wires are a bit haphazard down there. I'm a bit worried about them touching. Well, everything seems to be alright. So nothing's getting, my wire's not getting warm, so I'm alright. Anyway, so I've got all my coils wound. All the wires are sticking out here. I've just got to solder these wires up, and I'm going to do a test probably at the weekend. So I'm not rushing. I'm taking my time. I already test fitted the drawer, coil assembly. It all fits in there nice and snug. This part sticks out the end. It doesn't actually go in. That's why I made it a little bit bigger, so it won't actually go in to the drawer. I don't want it in the drawer because otherwise it can't suck any air in. So yeah, all these four do go into the drawer, and I've just got to wire this up and terminate some wires out this end, and my trigger coil out this end, and the fan is going to terminate at this end, so I don't always have to have it connected, but at some point I could have a little power unit. Oh, these little fans are about 120 milliamps each, so that would be 240 milliamps if they were in use. But obviously I'm not going to be using them all the time. It's just in case, just a precaution. I really don't want to be using fan cooling if I can help it, but I want to see how things go, determine how hot these things get. I'll just get my temperature thermometer gun and check the temperature periodically, and if it gets a bit too hot I'll just switch the fan on, and see if it brings the temperature down, see how well that works. So yeah, yeah, that's the update. I'm going to watch some videos and chill out a bit because my arm is still playing up. I've still got problems with my arm. It's been giving me a lot of jip. I got a Jabra alert a minute ago. I think I need to update my phone maybe. Don't know what that's all about, but yeah. So just to see how it goes together, and it's easy to swap my coils out as long as I don't melt the damn things. So if I want to try, you know, winding coils with a different gauge of wire or whatever, but I don't see why I should. Each one's 3.3 ohms, and they're going to be wired in series, so total would be around 9 ohms. Actually, let's see, that's actually 9.9 ohms. It'd be about 10 ohms actually total, because this one was a bit higher than 3.2. I think this middle one was about 3.5. So yeah, it's going to be about 10 ohm DC resistance across all of these coils. So it's 28 SWG wire. I didn't count the turns. I knew what I was aiming for, just to populate the whole bobbin really with wire. So I'll just basically adjust the voltage according to what they need really. And current wise, we'll see. Anyway, they should be much more efficient. I did some little tests on this actually. I did some tests on one of these coils to see how much propulsion it has, and it's much better than the previous coils. Much better. I don't know if I can show you that actually. I don't know if I can do that, but let's see if I can put my magnet drum on here. I'll see if I can hook it up. If I can just energize this middle coil with some juice. Let's turn the fan off a minute. Right, I've disconnected the fan, so that's stopped. I'm just gonna hook up this lead to this wire here. Oops, it's stuck to the damn magnet now. Oops. Need to bend it out of the way and get my other clip, and let's just pulse and see what happens. It's got quite a kick on it, by the way, if it's in the right position. See that? It moved. Let's try that again. It's got quite a kick on it. Look at that. It's just touched the wire and it's spinning really quickly. Let's try that again when it stops. Oh, it's in the attraction. I need to get it past this pole because it wants to repulse. Right, watch this one. just need to, there you go. That's just one coil, and that's 11 volts. So it looks like this thing is going to work at about 11 volts anyway. I mean, they're all going to be wired in series though. It's in pull mode. I need to put it to the other pole again. Obviously, it's got no control circuit on here. I'm just doing it by guessing. So anyway, you can see it works. Get the timing just right, it really kicks, it really moves. Definitely works. So yeah, we're gonna see what that does at the weekend. Hope you enjoyed the update. I mean, pulsing it manually is not the ideal situation, but at least you can get some idea. Anyway, at least you know it's going to work, because it can move that thing. So there's going to be 3 of these all pulsing my magnet drums in there. So 3 of the magnet drums will be pulsed, and the other magnet drum will be providing the timing on this coil. So, but they're all of these drums are actually linked together now. That is, they're all bonded together solid, so they're one solid lump. So there's no actual slippage or torque being exerted on the rotor, on the drive shaft, because the actual drums are all connected, molded with a collar that goes between all the drums. I think I showed you in a previous video anyway. So they're all one solid mass basically. So I've got no worries about torque and slippage on the drive shaft, because the drive shaft itself is just carrying the weight, that's all. Except when I'm starting it, I have to put some torque through the end. That's the only time it really has torque on there. So thank you for watching. We're gonna have some fun at the weekend, I hope.